The mesh is imported. Let us create the domains. Before that, we can specify the materials. Expand materials. Here we can see aluminum and water already available. We have to create the other materials, that is lithium, silicon and PCB material. We shall create them at first. Right click materials and insert material. We shall create lithium material at first. Click OK. It will be a pure substance. Check thermodynamic state and change the state to solid. Go to material properties. The molar mass of lithium is 6.94 kg per kilomole. The density is 534 kg per meter cube. The specific heat capacity is 3580 joule per kg per Kelvin. Next, expand transport properties and specify thermal conductivity. It is 84 watts per meter per Kelvin. Okay. Similarly, we can create the other two materials, silicon and PCB. Click OK. Next, we shall create the PCB material. This one is solid. The molar mass is 1. The density is 1250. The specific heat is 1300. And the thermal conductivity is 390. Okay. We have specified all the materials required for this analysis. Next, we shall create the domains. Right click flow analysis, insert domain. This will be add domain. Click OK. You can choose the location from here. Press the down arrow. It will be showing the options. The add domain is B274. The domain type is fluid domain. In the option, you can change it to air ideal gas. Keep the reference pressure as 0 atmosphere. Go to fluid models and change the heat transfer option to thermal energy. Click OK. Next, we shall create the other domains. We will start with battery. Insert domain. Click in the location box and press down arrow. The battery domain is selected. This will be a solid domain and the material is lithium. Go to solid models and keep the heat transfer option as thermal energy. Click OK. Next, we shall create the CPU. Right click flow analysis, insert domain, CPU. Select the location by pressing the down arrow. Change the domain type to solid. Specify the material as silicon. Click OK. Next, we shall create the PCB domain. In the location, you can select the PCB body and change the domain type to solid. The material is PCB material. This one is thermal energy. Click OK. There are two more domains left with the fin body and the component. Right click, insert domain, type fins, press here and select the fin domain by pressing down arrow. Change the material to aluminum. Click OK. Finally, we shall create the component material. Right click, insert domain, select the component and change the material to aluminum. Click OK. All the domains are now created. There are 6 domains in total: PCB, fins, the component, CPU, battery and the air domain. Next, we have to do 3 things, that is creating the boundary conditions, specifying the power input sources and creating the interfaces. We shall start with creating the boundary conditions. Right click add domain, insert boundary, type inlet. It has automatically chosen the inlet region. In the boundary details, we shall specify the speed and temperature. As discussed earlier, in the first case, the inlet velocity is 5 meter per second and the temperature is 15 degrees Celsius. Outlet pressure is 1 atmosphere. We shall specify these conditions. Inlet velocity is 5 meter per second and the temperature is 15 degrees Celsius. Click OK. We shall create the outlet region next. Right click add domain, insert, boundary, outlet. It has chosen the outlet region. Go to boundary details. The pressure is 1 atmosphere. Click OK. Next we shall create the boundary for the enclosure, that is wall domain. Insert boundary. We can type enclosure. This will be wall boundary. It has selected the enclosure region. We can keep heat transfer options adiabatic. We will be considering only the heat transfer option inside this domain, not from the external to this casing. Click OK. All the boundary conditions are specified. The next part is to create power sources. Right click battery, insert, subdomain. We can type battery power. Click OK. In the location, select the option B32. It represents the battery domain. Go to sources, click sources, select energy, change the option to total source. We shall specify the power input here. For battery, the power input is 10 watts. We shall specify it here. 10 watts. As we have discussed earlier, this unit corresponds to watts. Click OK. Next, we shall specify the power input for CPU. Right click CPU, insert, subdomain, type CPU power. Click OK. In the location, select the CPU domain. We are selecting subdomain inside the same domain. Go to sources, click sources, select energy, change it to total source. The total source for CPU is 35 watts. This is 35 watts. Click OK. The power sources are specified. Next, we have to create the interfaces. This is the important part. If you see in the interfaces here, by default, the software has chosen two interfaces. That is default fluid to solid interface, that is between the air domain and the solid bodies. Next is default solid to solid interface, that is between the PCB and the other solid components. We shall check them one by one. Double click default fluid to solid interface. If you click this box, you can see all the regions are selected except the enclosure, inlet and outlet. All the regions are selected. Here there are 6 regions left out. These are nothing but the first 3, inlet, outlet and enclosure. These are given separate names here. Okay. Now the software has automatically selected the regions which will be given interface with the solid domain. Next, coming to the interface side 2, it has chosen battery, CPU, components, pins and PCB, all the solid domains and the corresponding interface regions. All the common regions are selected here. Click OK. Go to additional interface models, select heat transfer and in the option you can leave this as conservative interface flux. Need not give any other option other than none in the interface model. Click OK. Now the default interface between fluid to solid is specified. Next we can check the default solid to solid interface, that is the interface between the PCB and the 3 solid bodies which are in direct contact. Double click this. In the domain side 1 we can see battery, CPU and component, and on the domain side 2 we can see PCB. Here it has automatically chosen the common regions. Anyway, we can check one by one. In the first side we can see there are 3 regions selected. All these 3 regions corresponds to solid to PCB interface which we have specified earlier. We can select this anyway. Click OK. Similarly, on the interface side 2, go to the region list and select PCB to solid interface. Click OK. Go to the next tab, specify heat transfer. Need not change any other option in this interface model. Click OK. Next, we have to specify the last interface, that is between the fins and the CPU. Right click interface, insert domain interface. You can type CPU to fins. Click OK. Choose the interface type as solid to solid. In the domain region 1, you can choose CPU. On the region 2, you can choose fins. It has automatically chosen the interface regions. On the side 1, it is CPU to fin interface, and on the side 2, it is fin to CPU interface. Go to additional interface models, and select heat transfer. Click OK. All the three interfaces are given here, that is CPU to fins, fluid to solid interface, that is between the air domain and the solid components. Next, solid to solid, that is between the PCB and the three components which are in direct contact. Okay. Moving ahead, we shall specify the solver parameters and create the expressions. Go to solver control, change the option to high resolution. Let us keep 300 iterations as the maximum iterations. In the residual target, you can change it to 10 power minus 6. Click OK. Go to expressions, insert new expression. This will be maximum temperature on PCB. Let us write the expression. Let us create the expression. Right click, functions, locator based. Here you can choose maximum value of, right click again, variables, select temperature. We can select the 3D domain PCB. So this expression will calculate the maximum value of temperature anywhere on the PCB. Click apply. Let us go to the output control and create a monitor point. Select monitor objects, create a new monitor object, PCB maximum temperature. Click OK. In the option, select expression, right click, expression and max temperature PCB. Click OK. The case setup is finally complete. Let me quickly summarize what are the steps we followed in preprocessor. After importing the mesh, we created the materials at first, followed by specifying the domains for 6 regions. Next, we created the boundary conditions for the air domain, that is inlet, outlet and the enclosure walls. Next, we specified the power sources for the CPU and also the battery. And then we created the interfaces. This is the important part. We created the interfaces between fluid to solid, that is from the air domain to all solid domain, and solid to solid, that is PCB to the components which are sitting on the PCB, and finally solid to solid, that is between the CPU and the fins. After specifying the interfaces, we created the solver settings and the expressions for monitoring. These are the major steps done in preprocessor. Let us minimize this and go to solver. Right click solution and click edit. We can change the run mode to parallel. Let us keep 5 partitions. We can start the run. The solver has started. We can check the user points. Okay, it is changing. Let us check the results after a while.